you very much for inviting me here today to talk about indoor air quality. So as you all know, indoor air quality is a subcomponent of indoor environmental quality, but it's generally taken to be defined as referring to the air quality in and around our buildings, which should be free from harmful pollutants that could potentially impact on the health and well-being of our comfort, or the comfort of our occupants. And in general, air quality starts to deteriorate when we build up indoor pollutants. And typically, they would come from one of three sources. So building materials and furnishings, so our textiles, fabrics, furniture, glues, adhesives that we bring into our homes mostly contain lots of different chemicals that off gas over time. In many cases, we don't have control over this particular source. Occupant behaviours, so smoking at home, cooking at home, burning candles and incense, they will all generate various levels of different indoor pollutants. We do have control to a certain extent over that source. And then outdoor air, like urban pollution sources, such as traffic pollution, but also industrial pollution, and then geographical locations. So thinking here like a radon, if you live in a high radon area, then that would be a source of indoor pollution. In terms of controls, so what I mean by there is how do we reduce our exposure to indoor pollutants? If we take the hierarchical controls approach, which is in our legislation, in the health and safety legislation at least, source is the main, is the top of the hierarchy, so it's the best way to control indoor exposure, just not bring stuff in the first place. And then after that, the next best available option, of course, is engineering controls, and what we have there is ventilation. So we need good general ventilation, but also we need local ventilation, so for we're generating pollution from things like cooking, for example. Now, I know we're talking about indoor air, but really, I suppose it probably is better to talk about just indoor pollutants, because we can get exposed to pollution in many different ways. Yes, the main exposure pathway is inhalation, so if there's pollution in the air, we're breathing in thousands of litres of air every day, we don't control, we can't filter that unless you're wearing a mask all the time. So, you're going to bring that pollution in with you. But you also have dermal and ingestion and exposure routes. So we know now, for example, that things like flame retardants and textiles and upholstery goods are all treated with flame retardants. Some of them can absorb through your skin dermally. And of course, pesticides are another example of chemicals that probably not used that much indoors unless you have pets, that can be absorbed as well through the skin quite readily. Ingestion is an important exposure route for younger kids. Toddlers, there's a lot of hand-to-mouth contact. So again, good example here, there's been a lot of research done in the UK on this, looking at exposure to flame retardants. So in the past few decades, we've been using a class of flame retardants called additive flame retardants. Over time, they actually leach out of your product and they petition in the dust and also air. But if you've a toddler and there's a lot of hand-to-mouth contact going on there, then you can bring the exposure in through the dust, and that has been already measured. We're all interested in this whole area of indoor air and exposure to indoors in our homes because we know that many of the pollutants that we get exposed to, they are risk factors in development of many different diseases. Now, we don't really have a great handle on that in Ireland, and that we don't know what the relationship is between exposure and health, but there's a lot of research in that space, and I think we'll probably hear a lot more about that in the next number of years. But these are the principal causes of death in Ireland, statistics from quarter 2, 21. You can see that respiratory and circulatory diseases make up most of the principal causes. Now, we know as well that chronic illnesses are on the increase, and Ireland has the fourth highest prevalence of asthma in the world. We have the third highest rate of COPD, and of course then lung cancer is the leading cause of cancer in Ireland, 1 in 10 attributed to daytime. So we're not saying that all of this is due to indoor air, but certainly there are pollutants indoors that we definitely know are risk factors in development, especially of respiratory diseases. And anyone who's an asthmatic will know that if you're in a freshly painted room smell, feel, scenes, it certainly aggravate your symptoms. In terms of costing all of this, as I said, we don't have a cost estimate on what exposure costs in Ireland, but others have tried to estimate that. So, for example, in France, there was a health impact assessment done in 2017 where they just looked at the socio-economic cost of exposure due to what we call 5 priority pollutants, and they estimated that to be worth about 20 billion. There's also another EU health fund project that estimated that exposure to indoor air pollution alone is probably costing about 2.1 million DALYs. That's the WHO metric, disability adjusted life years. And then finally, of course, you know, the Health and Homes Barometer reports, you know, more recently in the past 12 months, they've estimated that 26 million European children are living in healthy homes across Europe. So in terms of guidelines for any of these pollutants, so unlike water and unlike outdoor air, we have guidelines for indoor air pollutants, but we don't have any kind of mandatory monitoring or enforcement. Okay, and it's the same thing with ventilation. So we're not going to drink dirty water. We won't drink water that's contaminated with X, Y, and Z. But you know, we're breathing this air all the time, and we're not really. It's not on anyone's radar. Outdoor air is on our radar, but indoor air isn't. And we have guidelines there from the WHO and other organisations such as ATSCR and also EFSA and others. I suppose the big challenge, of course, is that, you know, the number of new and emerging pollutants in the market coming in, you know, in on the market every year is increasing at a huge rate. And we have a limited knowledge in terms of the health, the human health toxicology of a handful of those. We've made great strides in measurement, so we're able to measure lots of things, and we're continuing to measure lots of new things, but unfortunately for a lot of us, we're not really sure what the impact is on health. For some of the common indoor pollutants, and there's a lot more than this list, we do have a good understanding of the relationship between exposure and health, so we've heard lots of these, I'm sure, no doubt before. So particulate matter, for example, the volatile organic carbons such as formaldehyde and limonene, NO2, carbon monoxide, ozone. So we have lots of information there on the relationship between exposure to these pollutants and health. And there have been really proper health impact assessments done in the US, for example. Logue et al. She looked at a health impact assessment of exposure to indoor air and was able to show that particulate matter alone and also volatiles such as acrylamide and formaldehyde were accounting for the vast number of DALY losses, or the disability adjusted life years, in terms of health impact. This health fund project as well that I mentioned earlier, it's a European project. They also estimated that in Europe, particulate matter really is driving you know, most of the DALYs associated with exposure to indoor air pollution. But a lot of this, a lot of those particulates, they estimate that is you know, originating outdoors, coming back into the homes. So just to finish off our presentation, I just thought we might talk in terms of what we know about some of these pollutants in the Irish context. Again, looking at the different sources. So if we look at occupant behaviour, particulate matter is a good example of a pollutant that's generated through anthropogenic activities mainly. And you know, we know in Ireland, for example, 70% of the residential sector is reliant on fossil fuel, and we burn fossil fuels to generate PM. Smoking is another activity that occurs when it occurs, especially for tobacco-based products. When that occurs indoors, that totally dominates the particulate loading. And then, of course, we have e-cigarettes as well. And there's other activities as well, like candle burning, incense, you know, cooking. All of these activities generate particulates. The last speaker mentioned outdoor PM. EPA have an excellent ambient air quality network of measuring particulates in many other towns and cities across Ireland. This is an example of one of some of the data from a site actually in South Dublin. The black line there is the hourly average particulate concentration, and the red limit there, the red line there is the WHO limit, and that's the old limit. The limits have actually gone down since last September for particulates, but you can see that we regularly exceed, you know, the the WHO limit for particulates in outdoor air. And that study went further. There's a study published by colleagues at NUI Galway that actually wanted to try and identify, the source of this pollution, and most of it is coming from fossil fuel burning for heating. Now, of course, it's not all doom and gloom. There is a government goal to reduce our reliance on fossil fuels by 2050, which should help, the outdoor air pollution arising from that particular source. And just, I suppose, a question I'd have for this group is, as we move to more energy efficient homes, and we're mechanical ventilation, and we're bringing air in from outside. And when we have this excellent data available from the EPA monitoring network, we need to be able to use it and identify when we need to clean out the air. It's something we're not really good at, I think, in this country. It's kind of identifying when, we have outdoor pollution events, and we're bringing that air in then, and bringing the particulate back into the house, and it becomes an issue for you. I'd also like to just share some recent data that we've collected, again on particulates, and these are for deep energy retrofitted buildings. So this data was just published in the last month. There's a number of different pollutants: indoor air quality, thermal comfort, and ventilation, and deep energy retrofitted Irish dwellings. It's a sample of 14 homes that have been retrofitted in the last 3 years. And it was kind of a detailed analysis of a number of different pollutants in the homes made over a period of time, and questionnaire surveys completed, etc. So this is a stack plot, so it's the concentrations we record in the bedrooms and also the living rooms, and each stack refers to data from one house, and it's color coded. So the colors to look at are the grey and the purple, because they refer to the percentage of time that the concentrations in the homes were above the WHO limit. So the grey is greater than the older limit of 25 microgram per meters cubed. That's a 24-hour limit. And then purple is the new limit, which was introduced last September. So you can see that there's quite a lot of grey and purple bars going on in those houses. We have a lot of activity diary data for these homes. We're able to identify that most of it really is occupant generated. So occupant generated, but they're all mechanically ventilated. A few met the ventilation requirements in the NSCI 54, which was the guidance at the time that these homes were renovated, and even fewer would meet the current requirements in Part F. Now, a lot of the systems that were installed, are capable, I'd say, of complying. But the issue seems to be really around maintenance. And following on from the study, we have had lots of conversations with homeowners and then also the retrofit providers. This is just a picture that was provided to me a few weeks ago from one of the homes that they went back to the retrofit provider because they weren't happy with the results that they got in the surveys, and the engineer went out to have a look at the ventilation system. This home is only 3 years post retrofit. This is the addition of fan in the ventilation system, and once the system was cleaned, yes, the system went back to complying with what it should be in terms of the airflow requirements in Part F. So that's a bit of I think that's just a question again we need to consider, how do we consider the ongoing maintenance and performance of mechanical ventilation systems, because that's the way forward. One other thing I just wanted to show or mention as well is that people are really, really happy with the retrofit process. They were very, very happy with the thermal comfort in their homes post retrofit, and they were also really happy with the air quality in their homes post retrofit. So you can see that this is very complicated. So we can't perceive, we can't detect the concentrations that are that we're measuring, and even though we were detecting concentrations above recommended health limits, people were still very happy with what we thought was the air quality in the home. So it's quite complex, very complex. A lot of learning and teaching needed, I think, in the area. There was I think people were burning a lot of candles and incense, but the ventilation systems didn't work. But also huge, very low reported use of cooker hoods in any homes. So when people cook, they just weren't turning on the cooker hoods. You could see that was kind of generating a lot of PM. And that's something as well. I mean, how do we make people more aware of how, you know, these sources in the home and how do we get people to use it in the home as it's intended, and the ventilation systems provided. Okay, and then finally, just I'll race through the next one. It's you know, we're all familiar with radon. It's a class 1 carcinogen. Probably seen the recently published revised radon map for Ireland. My colleague James McGrath, who's here today, he's just published again some Irish data on radon, and you know, based on their research, you know, that they're warning that energy retrofit, you know, it's not properly managed, could lead to increased levels of radon in homes. This is something we need to be careful of. And particularly worrying finding is that, you know, that the low uptake of radon remediation. So even when people do find out that they have high radon levels in their homes, they're slow to kind of do anything about it, which is something that worrying. And then finally, building materials and furnishings. So this is, you know, this is almost like low-hanging fruit, I think, because, you know, we're bringing in materials into our homes all the time, and they're off-gassing various chemicals, and they're creating an issue. If we could control this at source, then we could definitely help avoid some of these issues, and not try and fix it with ventilation, even though we do obviously need ventilation for other reasons. Just a few things, I suppose. Flame retardants, so you probably know in Ireland Ireland and the UK have the most stringent flammability standards for polluted furniture in Europe. And for that reason, in order to comply with those standards, we've had to be adding various flame retardants to different goods down through the years. And many of these chemicals are now banned or restricted. However, they're still in the system, and they're now registered as persistent organic pollutants, many of them. You know, they're an issue. Then volatile organic carbon or chemicals, you know, they're off-gassed from furnishings, foams, carpets, glues, adhesives, you know, we need to try and encourage, I suppose, cleaner manufacturing and reduce this particular source. Again, just from our recent study on deep energy retrofit, this is actually some data on formaldehyde from Irish homes. So we actually measured formaldehyde over a 3-day period in bedrooms and living rooms. The ATSCR long-term chronic exposure limit for formaldehyde is 10 microgram per meters cubed. So those are the kind of concentrations we were measuring. Now this isn't unique to Ireland, but it is on the higher end of what's been reported for Europe. But you can see the WHO have a 30-minute limit of 100 microgram per meters cubed. So some of the houses aren't far off that. Now, we were able to identify what was causing these peaks. So people had been doing, this house here was doing a lot of cleaning during the monitoring period, but these homes here had actually in the last 3 months done a bit of paint work in the house. So it's probably kind of driving the levels. So as we kind of build and retrofit, I suppose we need to kind of push for more environmentally friendly alternative non-PAPs, flame retardants, but also chemicals. We need to kind of question as to whether or not we need to be applying flame retardants to children's materials like toys and mattresses and all this other stuff that this stuff is put into. And we need to be able to kind of visualize, I suppose, in terms of some sort of label, you know, how does, as we buy a product, you know, in terms of VOCs, how much will be off-gassing over the life of the product. So, for example, some European countries like France and Germany actually have a mandatory label, VOC label, that's put on construction products. We don't have that in Ireland. That definitely would be something, a good way of kind of communicating the risk, I think, associated with some of this stuff. So finally, not to end on a doom gloom note, but you know, retrofit ANZ, you know, definitely offers an opportunity to bring our buildings in line with health and wellbeing standards. We have an excellent opportunity now, and we should take it. Just a few ideas, I suppose, how we could improve things. Maybe we need a code of practice on indoor environmental quality to support the retrofit process. You know, we've got a lot of good stuff, you know, a lot of good guidance out there. We've got guidance that's relevant to the Health and Safety Authority. We have our building regs, advised for DEF, NSCI's guidance, but it's all very fragmented, so we could kind of pull that all together and help to increase an awareness amongst, I suppose, everyone that's works from design to commissioning phase with regard to indoor air. In terms of regulation, we're not going to be able to measure and monitor and regulate indoor air for all the different pollutants that we can detect indoors. But one of them that we should be considering, I think, is radon. Can we make radon monitoring mandatory as part of retrofit? I think it's important. There's an opportunity there. We should grab that. In terms of ventilation, Part F has done a lot in terms of the requirement now for third parties checking on the ventilation systems that are installed. It's not addressing the maintenance, and from the studies that we've done, maintenance, and anyone here working in ventilation, Jason here, you know that maintenance is an issue. And then, of course, construction products regulations and labelling. There is my understanding is that this regulation, this directive has been revised at the moment. As I said, many European countries have product labelling systems that are mandatory. That would be a good vehicle to kind of try and introduce here. And then finally, outreach and education. So all of the studies that we've been doing over the last number of years on indoor air quality in homes, indoor air is not on anyone's agenda. Nowhere like what we've had where outdoor air is. So we need to get this into the curricula. And actually, it was interesting. I was delighted to see this year in the Leaving Cert Honours Home Economics paper, there was a question on ventilation. And the importance of ventilation in homes, which I thought was great. They obviously covered it in that curriculum, and also stuff about energy retrofit or energy and insulating your home. So that's good. That's all positive, but I think we probably need to start educating them earlier. Okay, thank you.